Alright, good afternoon everyone. Welcome to the second lecture in COMP2041 slash COMP9044. Where are we up to? Well, some students have had their first tutorial and lab. Hopefully you made it there, and hopefully your tutor was there to help you. And some students will still have them to come this week. A reminder that for every week's lab exercises, they have to be submitted with Give to get marks. So the lab exercises have instructions about how to submit them with Give. You have to do that submission with Give to get marks. The lab exercises are normally due Monday of the following week, but because we've got people coming into the course late, we've got a week's extension for this week only. So there's an extra week for this week only, but from then on it'll be due Monday of the following week, Monday noon of the following week, just before the first lecture of the following week. You'll have seen in this week's lab exercises, we tried to throw in some extra questions to keep people who are finding the standard exercises easy, give them something to do. And this week is typical. I think the challenge exercise this week have one sort of sensible challenge exercise and one sort of...
There's actually no challenge exercises this week.
No challenge exercise this week?
All standard this week. Next week we will start with having a couple of challenge exercises at the end.
We don't have the match the brackets in the regular expression in this week's... Oh, I'm sad.
That's next week, I believe.
That's next week's. All right, so next week's we'll have some interesting challenge exercise. Sorry. Yeah, we do like not to put much into week one because we're just worried about... we don't want to... because it's only students coming in late. Everyone's confused and there are problems in week one. Dylan was just telling me about problems in other courses where new students weren't getting home directories, which made it hard for them to start in their programming in COMP2041. All right. Now, please try and access the course forum. Join the course forum. It's our main, outside your tute and your lab, it's your main way to get help. We will have help sessions starting in, I think, 2 weeks' time. But course forum is lots of information. A huge source of help and information in this course. So it makes us very sad if you can't access the course forum. If you've used the EdSTEM, the platform, before, you may have to do some interesting things to make sure you can access the course forum, but the instructions are in my email. So please try and access the course forum, and if it doesn't work, read my email. There's a contact for the class email there if you still can't get into the course forum after following the instructions. All right. That voice you heard was Dylan, someone's complaining your audio is not very good, Dylan. I'm not sure if it's coming through from my side or why that is.
I've turned it up on my end a little bit. But before we get started, I just want to mention something I've been seeing a bit in the labs this week, which is that there's been a bunch of students working together, helping each other understand regular expressions, and that's great. It's encouraged. If you have someone sitting near you who's not understanding something, if you can provide some assistance, that's awesome. But lab exercises are individual. You can provide assistance, you can explain regular expressions, but you can't show them your solutions. You can come up with another example. You can't say, here's my answer for question 2. This is what it's doing. So
what I really want is for you to learn. If you just copy someone's answer and hand it in, you'll learn nothing. But if you help another student see the problem with their answer, and that helps them learn. So that's what we're all about. Everyone learning here. So helping someone fix a bug in their solution, great. Giving them your solution, no, that's no good for anyone. All right. Thank you for that, Dylan. So hopefully, by the way, we haven't got lab assistants this week, but Dylan says I think we've lined up people for next week on. So all the CSE courses are big this term. It's our biggest ever term, and so we're struggling to find tutors. But Dylan has worked hard, and I think he has lab assistants sorted out. So there'll be 2 people in the labs as of next week to help you. Right, let's get on to the course topic. Leeters asking why did we dump Perl. Yes, some of us are a bit sad about Perl. We're very fond of Perl. Perl has become steadily less important. That was the big news both in my email and the first lecture. This course has taught Perl forever. We're no longer teaching Perl. We're teaching the same sort of topics with Python, teaching how to do the same things with Python. But it's just that Perl has become less and less used. When this course first started using it, it was the crucial language. It was the most widespread language for a lot of tasks, particularly revolving around the web. These days, not nearly as much. And it's a matter of balance. Perl, I still use Perl to do things. Perl's not a bad thing to know, but we have to choose what to put in this course. Yes, it was a bit of musical chairs because COMP2041 is moving from Python to JavaScript, and we are moving to Python, which will all there'll be a little bit of confusion, but it's actually good. We knew about this. All right. So the last lecture we talked about Unix filters. What's a filter? It's just a program that sort of fits a particular pattern of use. What's the pattern of use? It takes its input from one of two places. If you don't tell it anything, you don't give it any command line arguments saying where to take its input from, it reads its input from standard in. Otherwise, but if you give it command line arguments, it assumes their files, opens them in turn, and reads its input from them. And then writes its output to standard output, and usually it performs some transformation. The transformation might be minor or it might be huge, and we'll see examples of these to come. Typically filters are line by line things, but they can be character by character or byte by byte operations as well. So it's this useful set of programs. Why do you care about this? Because if you know how to combine several of these filters together, you can often do in a single line of code on a command line, talking to your shell, what would take you half an hour or an hour to code up in Python and probably more in C, and you can do it with less bugs as well. So they're great for a lot of transformations. Oh, yeah, I guess one thing I forgot in the first lecture, I was just thinking about before this lecture, sorry to jump about, but there is a question of should you be in this course? So if you're in a bioinformatics or software engineering degree, yeah, this course is required, so yes, you definitely should be here. This course is really strongly recommended for people in computer science degrees. And we don't get many computer engineers. It's fine to take the course, but it's a bit of a struggle to fit it into a computer engineering degree. Otherwise, if you're doing this purely as an elective, if you're interested in, if you like coding, if you want to be better at coding, this course is coding, more coding, so that's great. It's also, I mean, if you're into data science, this course will cover the sort of topics that you'd use to learn ways to clean data. So even if you're not so much into coding but need a means to an end, anywhere you manipulate large amounts of data, any sort of configure systems and that sort of thing, this course will teach you the things you need to know for that. So I would think, yeah, we don't get many people who enroll in the course and think, no, I shouldn't have taken that course, but the first week or two should give you the flavor anyway. All right. So Unix filters. We'll chain them together. We've shown you all of this. I don't want to recap that. Dylan gave us a lovely spiel on options. We talked about cat, the prototypical filter. Let's show you quickly actually no, it's in the last lecture, but I can get them. Two examples of code here. The simplest to filter. So this is the program cat. It just passes its input to its output. So you see the classic thing with a filter here. It checks to see if it's got command line arguments. If it doesn't, it reads. It takes its input from standard in. If it does, it opens them in turn and uses them as its inputs. Now, cat get byte, put byte. So that's as simple as you can get for a filter. So lots of filters do pretty much this bit. So this code here is more or less unchanged. It's present in principle in a lot of filters, but what the filters do instead is they replace this loop with something different. So they apply a transformation, and bear with me, I'll show you such a transformation. For those who don't program in C, and Python's your preferred thing, that's Python written up. There are a bit of questions there about what am I doing the right thing in terms of encodings there, but we're looking at the big picture. So that's the same thing in Python. Do I have command line arguments? If I don't, work on standard in. Otherwise, go through my command line arguments, treat them in files, and yes. You're saying you're doing this course as as an elective, and you're thinking, should I stay in this course? Do you like reading code to understand things? If the answer is yes, you're in the right course. If you hate it, maybe you should think about it, because I'll be showing you so much code in this course. Code, and more code.
An interesting note about this code that Andrew's showing here, that if we look at the process stream function, it's a single pass through the file. There's no backtracking. And what this means is that you'll notice this as we go through the next couple of weeks, that a filter, you can say in a filter to change something that's going to happen based on input. I can say change something about line 3 based on line 1, for example. But it's very difficult to say something change line 1 based on line 3. It's very difficult for a filter to change something previous, because that requires backtracking. That requires the file to be read multiple times. And filters, on a whole, do a single pass from start to end of the file.
Good point. Excellent point. All right. Well, come on. Oh no, I know it's not working. But it's not my day, is it? Oh no, I left them also in the old directory. All right. I want to just go through this example to show you. This is a simple implementation of grep, the filter we showed you in the first lecture, which, by the way, grep stands for Global Regular Expression Print. That won't be on the exam. This is a simple implementation of a what we call fixed grep. It doesn't do the clever things that I showed you in the last lecture for grep. But see how it's got the same main function as cat, but a different processing of its input. So there we're doing a simple thing. We're getting a line and saying, does this substring occur in the line? Then print it, which is the grep thing. Grep says prints a selection of the lines in its input. So it prints the lines in its input that match any one of a set of strings. And for your viewing pleasure, there's the same code in Python. I'll leave you to view those at your leisure. So what can we do with this? So you'll remember in the last lecture I had a file which has every UNSW course code and name on it. So if I wanted to search for, I did something like this to search for all the courses that mention computer or computing. And that's all the possible courses. I'll show you a few things about this to start with. Now, so the problem that grep has, and it's a problem many programs share, not just Unix filters, is they want a way for the user to specify a set of strings. There are a lot of tasks in computing where you want to be able to specify a set of strings and do something if this set of strings occurs. So you want a nice syntax for specifying a set of strings. Regular expressions are a way of specifying a set of strings. So a regular expression specifies a set of strings, a possibly infinite set of strings. In this case, it's very finite. That regular expression specifies two strings, computer or computing. And in the last lecture, we saw the little language and its syntax for doing this. It's deceptively simple, but incredibly powerful. So it can take a lot of practice to fully utilize the possibilities with regular expressions. And to give you a simple example of a different way of writing things, it'll specify the same string, set of strings. I can use brackets there, and that specifies the same set of strings. All right. Now. That's the program, grep. These here, we talked about, these are examples of command line options. They're not inputs to the program, they're modifications of the program's behavior. So the way of changing what the program might do. The -E one is a little silly these days. It's a bit of a historical artifact. It says, give me the full power of regular expressions. Last century you didn't want that because computers were slow. So unless your regular expression needed it, you wanted to turn off the full power to make your program run faster. These days you won't notice, and you almost always just want the full power of regular expressions. So you'll be forever typing -E there to say give me full regular expressions. The -I says ignore case, and you remember I waffled on about that, saying that's a big thing for programmers. Every time you're dealing with strings, every time you're comparing strings, matching strings, doing anything with strings, there should be a question in your mind of, programmers don't think enough about what they want to do with case. Sometimes case, whether letters are uppercase or lowercase, is really important. Many other times it's not, and you want to ignore it. Alright. So I'm hoping the stream has fixed itself. Dylan, is the stream okay now, or?
It did a buffer for a little bit. I haven't seen any more issues after that.
Okay, good. I hope we're all good. Alright. So -I is an example of an option. Now if you want to know what options a command has, you can say something like this, man grep, but be prepared to see a lot of information you don't need to know. So you're thinking, you know, Andrew must know all of this. Oh, one day to use grep you must need to know about all of this. No. So many of these options I've never used or don't understand. I've used grep a million times, and there are things there I've just got no idea about. Others I've used a while ago, and that's the classic use for manual entries. Is they're for someone who does a lot of programming, and use something and sort of knows it's there and it exists, and manual entries exist to refresh your memory. They're not so much so good for first year students learning the things for the first time. They're not so good at giving you an initial introduction. Now, the grep one is actually very well written for a manual entry. So you may want to look to other sources as well, but you've got to get good at reading manual entries as well. So often you'll have to do that. So you've got to learn this skill of look at this, ignore what you don't need to know, sort of skim through, find what you do need to know, and become good at that. Okay. Oh, there's an excellent question there in the chat, which I'll actually, I'll follow up with. So the question in the chat was, what if I just wanted to there we go. They're the 4 UNSW courses that have computer all in lowercase. What about if I want to ignore case for that letter and that letter only? Now, someone's come up with the classic way to do this. In the purest of mathematical regular expressions, you write it like that, and that works. But we talked about in the last lecture how there are shortcuts built into regular expressions, convenient syntax that let you describe things more simply. And this is I don't know what's happened there at all. There we go. And the convenient syntax for one letter is square brackets. So square brackets have a special meaning in regular expressions, which lets you succinctly say one letter will come from a set of possibilities, and you can invert the set as well. So that's the nicest way, the most convenient, the most readable way to write this letter can be either a capital C or a small c. If you're worried, you're worried about what this will allow you to have any vowel there, not just an E, which presumably won't come up. Presumably all UNSW courses are correctly spelled. Alright, Chewy is asking, grep -EI, can I combine the options? Generally you can do things like that, but CC has got these lovely computers where you can try these things out as well. Alright, so yeah.
Before we move on, man grep tells you how to use grep with the options. It doesn't really tell you about how to use regular expressions, but there is another command, infogrep, and infogrep has a whole bunch of information about the regular expression syntax that grep uses. If you want to check what is the syntax for character classes, what is the syntax for repetition, and you haven't got our lovely lecture slides available, you can use the infogrep command to find that.
Sadly, not on my computer.
You haven't got info on your computer? Interesting. It is available on CSC computers.
Alright, I could install it, but perhaps it's not the time. Yeah, actually, let's where was I up to? So this is the sort of pure regular expression. This alone suffices to do everything. So if you're a mathematician, you stop on this page, you don't bother with any more syntax, because anything, you can mathematically write any regular expression with this syntax, with these features. Now, as computer scientists, we're interested in other things like convenience and readability. So we want to be regular expressions add features that let us write them more simply, more accurately, with less bugs. So the syntax added, I go you examples of square brackets, lovely syntax. The up hat to invert the match, that's a bit horrible, but it's useful, I guess. Once anchoring matches, up hat and dollar. Repetition, the other repetition operators. So these are all convenience things for us. You can figure out how you can implement all of these in terms of the initial operators you saw. All right. Let's look at some example input. Oh, actually, no. All right. Yeah, let's look at some more examples. All right. Let's show you another filter. Let's show you WC. It's quite a useful filter. It reads its input. And really reduces it. So on its output, WC, however many lines of input you give it, either from files or stood in, produces only one line of output for each input source. And it tells you the number of lines, words, and characters. So you're thinking, I could probably write that. Yeah, well, you probably could. It's a classic student programming problem. and I've coded it up in C. You can check my coding, but there it is with processing a stream, and that's what it does. Every time it sees a new line, it increments the line count, and you can see its definition of a word is non-space characters. So that's WC. It has just and you want the same in Python, I guess. For our let me type that editor command in the correct window. For the Python programmers among you, there's my attempt at coding it up in Python, which is not too bad, I think. Again, you think you've got a nicer Python for that, you can send it in and we'll consider putting it up on the lecture pages instead of my Python. So that's WC. WC, if we check the manual entry, we can find out it has a few command line options. So let's see what we've got there. It's got options to print just the number of lines, just the number of characters, and do a few other things which we probably don't care about. Interesting, yeah. Just printing the number of lines is very useful, or just printing the number of characters. You're saying, Andrew, why would that be useful? I can read all three numbers. That's great. Yes, you can read all three numbers. If you're using WC interactively, that's fine to print out the three numbers and interpret them. But we often use WC inside scripts, shell scripts, so we're getting to that. And then you often just want one number. We run WC on the files in the current directory, and there's our output for it. A really useful program. Justin's asking, what does the :E do? It's colon gives me an editor command in VI, and E is to change files. Yes, I would recommend, by the way. So if you want to start fights and you've got two tutors in your lab, you can ask them which is the best editor. No one ever agrees about what the best editor is, but I would recommend that you do learn the editor you see me using here. At least a few simple skills in VI, because it works over simple connections, and it's relatively common to finish up on either a little embedded board or a cloud server or something like this, where you can't run Sublime Text or whatever your favorite, Visual Studio Code or whatever your favorite way is of editing, but you can run VI. So it's quite useful to be able to know a few commands in VI. Yes, Blake loves VS Code, not uncommon among our students, but yes, if you do things like SSH into your phone, you won't have VS Code, but you will have VI there inside your phone. If you want to edit a configuration file, for example. All right. Now, what did I want to? So I can do commands like this. That's fine. The other thing I can do is I can it's sometimes useful to put together greps. So we're looking for courses that mention computer. It can be hard to produce negatives in regular expressions. Not impossible, depending on the context. So we might be interested in computer courses not taught by School of Computing at UNSW or the School of Computing at ADFA in Canberra. Alright. The -V flag on grep is enormously useful. That says print the lines that don't match. You're saying, Andrew, but look, you've stuffed up here. Well, something's going wrong. You've said print lines that don't match ZITE, and that line does match ZITE. And that's because I forgot something. I forgot to put the flag I mentioned you always want, which is capital E, to say turn on the full power of regular expressions. If if you don't do the turn on everything, the vertical
you
bar.
need to move your head, Andrew.
Oh no, no. What I can do is probably, can I clear the screen? I don't want to move my head. It's actually, I can just switch the example to the other side. I can move my head, but all right. So that's now doing what we wanted. Oh, and you might try doing, yeah. Here might be, if I don't want comp or courses starting with Z, that's a way of writing it. How about that? That's quite a nice regular expression. All right, so that says, that up at there says anchor this match to the start of the line. Only match here at the start of the line. That says match COMP at the start of the line or Z at the start of the line. And the -V says print all but that. So that's using grep regular expressions. It's a little bit silly, some of the things I've done there, but that's giving me all the courses, so I can go out to sociology and say you shouldn't be teaching computer analysis of social data. They probably should be, actually. But these are other UNSW courses involving, which have the word computer in their title. I'm a little worried about this. The Gen Ed course, the computer impact significance, computers into the 21st century. Oh, I suspect that's an old course. All right, let's move on. Two more filters. My friends, head and tail. Things you'll use every day if you're working around data. Head gives you the first n lines of the file, or the n. It's a filter though. It gives you the first n lines of its input. So it's pretty common for me to say, oh, just show me the first lines of what this does. So you'll construct a chain of commands together, sometimes 5 or 10, and you say, oh, I just want to see what it does to see if it's working before we go further. So head just reads for 10 lines and stops. So it's like cat, but it stops after n lines. And you're thinking, if you're thinking, oh, I could code that up in C, Andrew, or I could code that up in Python. Yes, you could. It's not at all hard to code up, but an enormously useful program. And you'll often just use it to look at the top of a file. It gives you the first n lines. If you want a different n, you can specify it. There's a weird way. You can just say minus 42, I think, to get the first 42 lines. You can probably say it in another way like that, is it? Yeah, apparently. Of course, you don't have to take my word for it. You don't need me at all. You can just go man head, and there it is. There's all the information you needed. That's not too bad to read either. Tail is head's, bizarro friend, I guess. It does the last n lines of a file. So there's the last 10 lines of that file. So there's all this course code starting with Z. Right. Now, there's one thing we might not have covered. Did we cover? One thing to be aware of is white space. Lots of programs break because of invisible characters, non-printing characters. Cat has an option, -A, to show you invisible characters, and that's quite nice. There it is running, and it's showing me what's there. That's how a cat outputs a tab. You don't really have to worry about why it outputs a tab like that. But if you see that, you're thinking, that's actually a tab. That's not a sequence of spaces. That's a tab character, a single tab character. Does that matter? Well, it depends how you write your code. That can break lots of programs for sure. We'll show you how to write code that doesn't break in those circumstances, doesn't need to know whether there are spaces or tabs and handle that sort of thing. The other thing that keeps programs awake at night is spaces at the end of input are very hard to see. And we can see there, cat-a puts $1 at the end of the line to show us that there are no spaces there. So that's head and tail, which we can drop into pipelines. They're sort of cute. All right. So that file, course code and program codes, they're tab separated. There's only 2 fields in them, I guess, but what do I mean by that? Often we have columns, probably a fixed number of columns, but columns in a file. So each line of the file might be one record, one piece of information, but we might have separate, it might be broken down into separate components. Here we've just got 2 parts, course code, course name. In this case, you can have fixed length files, very little used in computing these days, and with text. You could have them because we know all course codes are 8 characters, so we could just have a file that assumed that. But a lot of tools work by having separators. We have a special character, and everything is so much easier if that character never appears in the fields. In this case, we're using a tab for that purpose. So we're saying we put a tab character there to separate the 2 fields, and that would commonly get called tab separated data. One thing you might notice here, a lot of people, it's pretty common to use a suffix on the end of a program to say what it is. So what have I got in this directory? Oh, look at this. So I've got wc.py to indicate that's a Python program, and wc.c to indicate that's a C program. That's not part of the operating system. It's not part of Unix or Linux. Some operating systems, unwisely, have built-in notions of what to do with suffix, but no, it's just a guideline. Admittedly, quite a few programs will look at those suffixes and do things based on them. So if you're browsing the file system, the file system browser might do something different for a .c file or a .py file or a .text file. So it might assume what's in the file based on the suffix. That's sort of sensible and useful. But that's not hardwired into the file in any way. And it's quite nice in that various programs sort of might make use of it. CLang is saying, Andrew, .py, I don't really know what to do with that. It does have options. I can tell you, I can give CLang options to say, well, look, that's really C code, compile it, and it will do it. But CLang is looking at the suffix there to say to guess what I mean. So it's not a bad practice here to indicate something about the file. So it might have been better if I called the course codes there, course codes maybe .tsv to mean it's tab separated data. So that might be sensible. Not a bad idea to do that. Not required by anything, but not a bad idea.
Text editors also generally use extensions for syntax highlighting as well. So if you were to open that course codes in a text editor, it would probably be blank. But if you put a .tsv, your text editor may be able to highlight that and understand what it should look like.
That all assumes you like syntax highlighting, which I don't, but so many students do. All right. Okay. That's an excellent point, actually. Yeah, that's another example where a tool using the suffix of a file to indicate what it thinks the context is, and then apply and then treat it that way. Well, Lorenzo's saying CSV is literally comma-separated data. Yeah, CSV tends to be there are a few CSV formats, but that's at the basic heart. They're comma-separated. Just like that data there is tab separated, they're comma separated. There's additional syntax depending on what flavor of CSV doesn't work. Lita is sad because cat-a doesn't work on a Mac. Yes, tell me about it. In theory, Macs have very Unix-like operating systems. In practice, they just never work like our CSV systems, and the way they differ just seems to change from year to year. But we'll teach you the skills. We'll help you learn the skills in this course to cope with, running software on your Mac, running things at work, running things on Amazon, the differences, how to write scripts that work everywhere, how to debug the problems, that sort of thing. It's just that we're all about handling things like that. All right. Now, I wanted to show you this enrollments file, which is an interesting format. So, in fact, we can make this wider. All right, first let me emphasize this is synthetic data. We're not infringing on student privacy here. And that's actually a theme of this course, is giving you the ways that you might easily construct synthetic data. So even if you end up in a C++ shop, you might end up using the tools, filters, or perhaps or Python in the way regular expressions, the stuff we cover in this course, to create synthetic data to test your C++. You probably use scripting and things like this for build suites and so on. But so this is a classic sort of download from a really old school download of student data. As I've said, completely invented. I got the real enrollments for this term and then just made up student numbers, made up names, made up everything that's there. But there's real data. Sorry, synthetic data, but real enough to test programs. Now, what did I want to do with this? Well, I guess it's got all the enrollments, so how do we find out? We can look at it. Doesn't seem to be in much of an order, does it? First, last, so we've inspected it there. We can pass it to WC and see how many there are. 11,355 enrollments in computing course, in comp courses this term. Alright, what more do we know? We can find out how many people are enrolled in COMP2041 this term. Watch me. I'll grep for COMP2041 and I'll pipe that to WC-L, and that should tell me how many people are enrolled in COMP2041 this term. And I can do the same for 9044 for our postgrad students. And I can do the same. Oh, I've been forgetting the -E flag, which is not needed for those really simple operations. Well, let's do it the nice way. Alright, so that's a perfect example of a task that would involve some coding. Maybe not so much coding, but we can do it faster with less bugs if we know how to use Unix filters. We want to know how many, we've got this enrollments file, we want to know how many people are in this course. There we go, grep from there. What could go wrong with that? Alright, let's have a closer look. Yeah, someone's pointed out in the chat, this is not comma separated, this is not tab character separated, but it is separated by a vertical bar. Actually, it's a bit, this is a really old school format in that it's also fixed format width, but we'll forget about that. We can just use the vertical bars there and they're the separators. They separate course code, student ID, name, program number, plan, and so on. Alright, what about if we're wondering about gender balance in the course? UNSW insists on putting an M or F next to students. Actually, I think there is a possibility these days to be something other than an M or F. But let's see how many people have an F there. So will that work? Is that going to give us the number of female students in the course? Huh. That looks pretty good. Yeah, a few people in the chat have spotted the problem. Right, let me give you a general piece of advice here. If you want to have some, if you can quickly do these things in the command line, but you really want some way to verify what's happening there. I guess one way would be a sort of integrity check. Is I could then work out. Well, I guess the best way is probably just to look at the data and scan through the data. So how might I do that? Rather than dump it into WC, I could just look at the first 10 line. Oh, I broke my regular expression. Look at the first 10 lines or the last 10 lines. Often that's enough, or you could scroll through it all. Now we're seeing things go wrong here, aren't we? Why is my regular expression picking up the very first student there, Wembo? It's meant to be only selecting students that got an F there. But that says COMP2041 2041 dot star F. You could actually get the, I'm not going to do it because it's take a little bit of time, but I could get that line and paste that into regex 101, that website I showed you, and the regular expression. Shall I try? Yeah, let's try it. What could go wrong with that? Online regex checker. Let's try it. I never use these regex checkers, but I've known regex expressions for a long time. So we'll put that data in as the test string. Alright, and we'll get our regular expression, which is this. Drop it in there. And we can see here it's telling us why this regular expression is matching. It's matching this part of the string. Oh look, it's that F there. Alright, so that's an example of using this regular expression checker to find out why a match is happening. And it's going to the F of fins. And yeah, a few people in the chat are jumping up and down saying, Andrew, I can see that. Yes, good. Good. So how do we stop that? And we've had the solution put in the chat as well. We're lucky here because we only want to match an F at the end of the line, so we can anchor the F there. It's not the only way to do this, but that should work. Okay, and that seems to be doing the job for us. So that might be telling us how many female students are in the course. Now, again, a reminder: this is there is no Karen Wang, no Amber Meow or so in this course. You're saying, Andrew, how did you come up with names? Yeah, well, you can think about it. I got a pile of I got the student data and got common last names, common first names, middle names, and sort of bundled them all together, randomly selected from them. You could perhaps write a script to do that. What else could go wrong with this? There is something to be aware of. We're looking for this string here, but well, what if it occurred in someone's name? There could be. Well, this course has been running a while. There could be someone whose parents so loved this course they gave them Hannah COMP2041 Natalie Yee. They gave COMP2041 or COMP9044 as a middle name. All right. It's not sounding so likely, though. If you want to go along in this vein, Google Bobby tables, and you'll find a very funny cartoon about that sort of thing, about why you shouldn't assume anything about names and being safe. But there's also there's this field here with plans. You're wondering, could they accidentally appear in a plan? Yeah, well, I don't know. So what might you do with that? Yeah. Leader suggesting yes. What about Elon Musk's kid is in the class? Yes. Yes. All right. Again, I'm in the fortunate situation that what I want to match against is at the start of the line, so I could actually add an up hat to anchor the comp to the start of the line and avoid that, and nothing changes. All right. What if Kay Shaw is asking, what if the structure's been changed and F is not the last character? Yeah, that's such a good question. These are the fears and things we live with, and it can be very hard to write robust code like this. You're often left with a lot of uncertainty. Now, if your task is to answer a question for someone, and that's the end of it, your code works now, and that's great. So it's a one-off task, or I'm cleaning up this data and I'm done. That's fine. Or is this code going in a script that's then going to be run in a cron job? It's going to be run daily, and for years to come. And then you have to worry about, is it going to be robust to changes? Is my input data always going to have formats? Yeah, 2022. Thank you, Leader. Yeah, UNSW UNSW was in parts of UNSW fully recognise the point you're making, but not its student information system yet. Quite. It will get there one day, we hope. I would point out that this is a format of data that really went out of fashion in the 1980s, and that's pretty common for information systems and things like this to be really old format data lying around. It's very common in companies and things like this. Universities, all sorts of organizations have data systems that are really old. So knowing the skills to transform these weird old formats into something more recent or more useful, transform it into, say, JSON, for example, is very useful. All right.
That UNSW does support non-binary gender by, I believe, they just add a dot instead. So there's 3 options: male, female, and dot in the actual data file.
I don't know why it's there at all, but anyway, it's let's not explore this very vexed topic and go to happy things where we can resolve. All right. Well, it's not a vexed topic. It's where UNSW could do better, will do better. Now, all right. Let me introduce a tool that's quite handy for handling this format data. The tool is called cut. It's useful for handling data that's separated by a particular character. So it can be used to say, give me parts of a line. The line is separated by a particular character. Cut defaults to a tab character, so I can say, for example, for the course codes file, just give me field 1 and it'll give me the course codes, or just give me field 2, it'll give me the course names, or I can even say give me both fields 1 and 2. This file's only got, you can also specify ranges, so I can specify ranges 1 to 7, even though this file's only got 2, and cut will happily do its job. Now,
can we talk about the sad thing about cut? This is the one thing that students really wish, I think everyone really wishes cut would do. If we get that first command and we swap the 2 and the 1, it would be really nice if cut would give us the data in a different order. But it won't. Cut, as I mentioned before, the way that filters work, it does a single pass through the file, start to end. You can't rearrange things. So 2.1 will do exactly the same thing as 1 and 2. It just says, I want field 2 and field 1 in the order that they appear.
Alright, so I can apply cut there. Cut has a -D option, which says the D is for delimiter. You can actually specify it probably like that as well, but I'm so used to it I just do a -D, and you put the character you want to delimit. And if I suppose I just wanted the ZIDs there, the student numbers, I could say that, and away I go. Alright, and I did that deliberately because, well, this is the classic issue you've got to get your head around. You've always got to worry about any unusual character. Who's going to interpret it? I'm passing it to a program. Will it get especially interpreted before it gets to my destination? So here I'm typing a command, I'm talking to a shell. The shell has characters it attaches special meaning to. We often call them meta characters, but special characters. And we've seen less than and greater than to redirect input and output. And we've already seen vertical bar as well as a special character. What that says to the shell is, oh, run these two programs and connect the standard output of the first one into the standard output of the next one. Now you're saying, well, why didn't the shell figure out cut takes that option? And no, that way lies insanity. Yes, it's true, the shell could know about the programs it's trying to run, but that just makes it impossible to update the shell, update the programs. You never know what you're doing. The alternative is to have a mechanism to say to the shell, no, that doesn't mean, run these two programs and combine and connect output to input. You can turn off the meaning. Let me show you 3 ways to do it. We'll later on cover some of the differences. I can use double quotes. I can use single quotes. Both of those say don't interpret what's in there. Or I can use a backslash. If in doubt, probably the best one to go with is single quotes. Double quotes have a meaning we'll get to in next week. Alright, so that's probably the best way to do it. So that's saying the same thing. The single quotes, yes, the single quotes don't get past a cut. The single quotes themselves have a special meaning to shell. They say, ignore whatever special meaning of the characters between me. Get rid of me, and don't treat the characters between me with any special meaning. So cut then just sees a vertical bar passed into its -D option. It says, great, Andrew wants to look at a file that's separated with vertical bars, with pipe symbols if you prefer, and does the right thing. So if I was just interested in maybe the ZID and the actually we'll go with the birth dates there, which I think it might be field 9. Let's find out if that works. No, so it'll be field 8. So how would I get students, find out how many students in my pretend data are born in 1999? We'll go with 1999. Again, we've got this is that right? So this first step is nice in that if we only care about these things, we've reduced our data down. It's a very common step in working with filters, is to trim the data down to the selection we wanted. Cuts hugely useful for that. One thing I would note is it has to be a single character there. You can't put a regular expression there in cut. There are functions in Python, for example, Perl, most regular expression libraries that let you do the same but with regular expression, but cut does not accept a regular expression. So what can have gone wrong here? Hopefully you've spotted the same theme. What happens if someone has 1999 in a student number? You're saying, well, how can we find out if there is anyone with 1999 in the student number? We can just cut the student numbers out of the file. That's the student numbers. And who happens to have 1999 in their student number? There would be one student. I've seen this before working with a huge set of student data where I've done things based on ZID, and you think, you can search any sort of data in ZID, and you'll be right. You won't get those 7 digits randomly. No, if you have enough, let me tell you, have enough data with mobile phone numbers in it, you occasionally will get someone who's got a mobile phone number which contains the ZID of another student.
Infinite monkeys and all that.
Yes. All right. So I want to finish this, and then I'm going to have a break. I need a break, but how would we grep for 1999 only in the student number? Oh, sorry, for people who there, we'd have to do this. There we go. This should give me all the people born in 1999. Oh, why has that failed? Why has that failed? The problem is this vertical bar here. What do I mean there? I mean an actual vertical bar. So I've got to get it past two things. I've got to get it past the shell, which will interpret it as pipe standard output to standard input. Then I've got to stop it being interpreted as the OR, alternation, union operator, whatever you want to call it, in the regular expression, which I can do with a backslash. And you've really got to think about these things. You've got to experiment, clarify your understanding. We have one big advantage over mathematicians in that some of these things we wrestle with are just as complicated, but we can execute them and check our understanding. So I can check that and see in this data set, oh, there are 1,020 students born in 1999. There's an issue here though, that they've got two the same. I'm double counting, and we'll come back to that after a break. So let's take a 5-minute break.
Just real quick before we go for the break, something that came up in the chat was what happens if we don't pass the hyphen D, and cut doesn't guess the delimiter. Cut uses tab. Tab is the default, which is why that works with our first example without needing to specify anything.
And there it just gives me the whole line. I don't understand why it's not giving me nothing, but anyway. Yeah, so it's best with cut.
Splitting, so without the delimiter, it's splitting on tabs, and there's no tabs. So everything is one field. So it should just give field 1. That is interesting. All
right. Anyway, let's all stretch, refresh, get up, and take a break, and back in a few minutes. All right, welcome back everyone. Hope you had a chance to get up and stretch or whatever. Do what I do, head to the kitchen and grab a cookie. On screen is a pipeline, a series of filters that are meant to count how many students at CSE are born in 1999 in our synthetic data. If we look, as I said, I've said now don't take these on face value. Have a look at various stages in the pipeline, scan through it, head and tail, and nice to look at the first and the last. And we can spot a problem there, can't we? In the ZIDs. Duplicate ZIDs there and sorry, in there. So we're double counting the students. Now, what do we do about that? Well, I have a program for you which eliminates duplicate lines if they follow each other. So if it sees two or more lines the same in a row, it doesn't print the second, third, fourth, and so on of them. You're thinking, could you write that program? I'm betting you could. I'm hoping you could. So let's have a look at what might be in that program. Oh, my C code looks a bit scary. Alright, so that's C code that does that, making quite clever. If you want to sharpen up your C programming skills, that's using realloc in a nice way, a nice robust way. What's nice about my C code? No limit on the length of a line. Is there a maximum line length? There's no maximum line length, we can easily assume. So that grows a buffer to cope with whatever line size is needed in the file. You can read that code at your leisure. You're saying, Andrew, it's probably easier in Python. Yeah, it probably is. What's my Python look like? So it's just, yeah, we can read the Python a bit better, isn't it? Yeah, so this says if it's our first line or the line is not equal to the last line, print it. So it doesn't print duplicate lines. We can try this out. What it does is say hello, it prints it out. Say Andrew, it prints it out. Say Andrew again, and it won't print it. No, it doesn't matter how many times I say Andrew, it eliminates the duplicates. Now, one crucial thing, one really important thing to note, which you might have seen in that code, is there's no memory in the code. It only prints it out if the last line doesn't matches. So if I put in Dylan, it'll print Dylan, but if I say Andrew again, it'll print Andrew this time. It's only because Andrew doesn't match Dylan. If I say Andrew again, it won't print, but it only eliminates duplicates in a row. So it's only useful if we want to eliminate duplicated lines one after another. Let me show you the code again so you can read it and see why. If you're a Python programmer, read that. It's just looking at the last line. So it's just comparing this line to the last line, and if it's different to the last line, we just print it out. Hey, wait. Why is the index needed there? I'm not sure that index is needed there. Anyway, let's not worry about optimizing my Python. You can optimize my Python for me. Right. Let's try it out in our data and see if it does the job for us. I'm only seeing one instance of every ZID. And only there. So I've eliminated the duplicate ZIDs as far as I can see, and I'm finding out there are really 596 students who are enrolled in 1,020 different courses. So there are 1,020 enrollments from students born in 1999, 596 different students. Now, this depends on all the enrolments for a particular ZID being together. So all the enrolments for 521446 being in a sequence. Do we know that? Sometimes we might, other times we don't. It would be nice to have then to combine with unique. Seems really useful, but it becomes much more useful with another tool to put lines in order, so any two lines that are the same are guaranteed to be next to each other. And I've got that tool for you, as you can expect. I've got it in C.
I can actually tell you that in our synthetic data they will always be next to each other. In the real data they are not.
Yes. So there's, well, more or less the code in C. Reads the lines into a gigantic array. Again, you want to be impress people with your C programming. Make sure you can use realloc like that to construct an array, and then calls qsort. All right. So if you come through COMP2041, there's doing a few things you might not have seen. Don't worry about that. That's not really. Don't we have it in Python? These are examples to give you. If you can read C, this is meant to show you what sort does. If you can read C, if you can read Python, oh, it's so much easier in Python, isn't it? Just call the sorted function, join it together with nothing, and print it out. Ah, lovely. That's the Python. So the sort reads its input, then prints it out, and it'll sort it. Alright, and it keeps reading until it's seen all its input. So it's atypical, and the filter script scene have just streamed stuff through. Sort must read all its input and then put its output. And there you go, there's its output. It's written out Andrew, Dylan, hello, hello. It's sorted. So it's very common then to first sort your data like that, and now you know that unique is going to see any two identical lines next to each other. So 99 times out of 100, if you're using the unique program to get rid of duplicate data, you do a sort beforehand to order your data. They go together. The exception would be is if you know your data is already sorted. Even then, if you're a careful programmer, sort of a paranoid programmer, you might still run the sort just in case there's something goes wrong. Now, what can we do now? There's a couple of things I wanted to do with that. So let's look for COMP2041 students. What plans?
Ooh, someone said something interesting in the chat. Sorting assumes data is numeric. No, sorting assumes data is alphabetic, actually, which means leading zeros make some very interesting things happen in sort.
So that's it. Sorting, yeah, assumes an order. So that's a superb point by Avijit in the chat, is ordering. What ordering are we sorting on? There's not just one ordering, is there? And the default ordering, as Dylan has said, is actually dictionary order, alphabetic ordering. We can check that. You're saying, let me show you if I put in 7, 8, 9. Oops. I don't know what I just did there. Sort. If I ask sort to sort 7, 8, 9, 10, 11, it puts 10 and 11 before 7, 8 and 9. There is a way out of that. If you use if your numbers are fixed size, dictionary ordering and numeric ordering are the same. So you'll sometimes see people do something like that, just so that they know that their numbers will get sorted correctly even if dictionary sorting is applied. Sort also has an option to say no sort on numbers. The dash, it has a numeric option. You can say no, my input's numbers, sort on numbers, and that will leave that unchanged. But yeah, great point, Avjit. You need to know what ordering is being applied. And
this is why we give you Lab 01 and not Lab 1 in our courses. But what sorting algorithm is applied? Don't know. It's internal to sort. You don't know what sorting algorithm is applied. It's something, and it is relatively efficient. You can go read the source code if you would like to figure out what it is. It's probably quicksort, because quicksort is very good, but no guarantee of what it is.
Doesn't tell me. Yeah, it's an interesting. Yeah, so that's an algorithms question there from Lorenzo. There are many sort algorithms with different properties, and which ones does the sort program use? And it has been incredibly optimized. It switches between algorithms depending on the nature of the data. It tries to use an algorithm that works well with almost any data, and it's changed a few times over the years. So I'm actually I'm out of date as to what algorithm it actually uses in there. What did I type to? I typed Control D to tell the operating system's end of input, and it passes to sort no more input. So yeah, that's excellent question. So I type in sort ABC, then I'm holding the Control key down and typing D. I used to have a keys program that showed what keys presses I was doing. I used to run that, but after that disclosed a password in one of my videos, I've stopped using that. Thank you for Tim and Stephen in the chat for answering that. Yes. Right. By the way, sort has an option to say sort on a particular field. Frustratingly, you tell it the field separated with the -T option. You're saying, shouldn't there be -D to be consistent with cut? In the best of possible worlds. I guess there are two things here. No, yes, it does make your life hard that these programs aren't easy to use, but people will pay you large amounts of money in future to be very good at handling these sort of problems and handling them well. So, and then I can say sort on field, and instead of an F, it's a K for sort. So I can say sort on name and enrollments like that, and this should give me the first names and the last names in this synthetic data. Sort has a -R option to reverse the sorting. The first become last and the last become first, which is often very useful. Now, what are we going to... Oh, all right. What was I going to do? I was going to get... What did I want to do? Maybe find out what plans people... Now let's get the COMP2041 students in this data and find out what their surnames are, and we'll see what's the popular surnames from the COMP2041 people. That's not a lab exercise next week, is it, Dylan?
Which one was this one?
Print the surnames of anyone enrolled in COMP2041.
Interesting question. I'll have a look.
Quick check before I give away the answer to next week's lab exercises. Yes, yeah, sorry Lisa, it is confusing. Yeah, it catches me regularly. You will have manual entries. This K here is the same as an F for cut. and this T is the same as a D for cut. And is there any reason they're different? No, there's no good reason they're different. But it's far too late to fix them. Dylan's checking the lab exercise. Alright, so this gives me the students enrolled in.
I think we're all good.
Good. Alright, let's see if we can find out the surnames, the family names of people enrolled in COMP2041 in this data. So the first thing we might do then is say to cut with a dash D, unlike the dash T of sort, saying the delimiter is a vertical bar. I'll put, I could have used a backslash, but I'll put single quotes around so the shell doesn't give it a special meaning. And say I want field 3. Alright. Let's make sure we'll put it into WC and see. Yep, it's looking like we're getting. So this is the names of all the people in the course in this data. How would I get the surnames? Well, this is sort of separated data. It's got a comma there, so we can tell cut. Yeah, look, it's comma separated data. Give me field 1. So we can look at what that does. So they're all the surnames, and we could perhaps sort them from first to last. Oh, we've seen this already, but there we go. And if we just want them, how many unique family names in the course? There we go. So I've chained a grep, passed its standard output into a cut, passed its standard output into another cut, passed its standard output into a sort, and then into a unique, and then a WC. So I count that as 6 programs running together, all typed in there to tell me how many different family names in students in the class. 223. Let me show you that the fun doesn't end here. Unique has an absolutely fantastic option. This is just about my all-time favorite Unix filter option, -C on unique. Let's see what that does. It prepends a count. So rather there were 7 Ahmeds and it reduced it to 1, but put for a count saying there were 7 Ahmeds, Andrew, or 3 Auroras, 5 Angs, and so on. We go to the end of the data. You can see there 6 Zans, 3 Zangs, 5 Zhaos. Apologies if that's your family name and I'm mispronouncing it. What can we do now? We can sort it again, and we can say do a numeric sort. And look what happens here. These are names that occur once. There's only 1 student with these family names in the class, so there's only 1 student with the family name of Gil, 1 of Hughes, 1 Duong, 1 Kai, going all the way through to 12 Shis, 10 Goes, and so on. 9 Kims. So we can find out then the most common name in the most popular names in the class. If you just want the single most popular names, yeah, apologies, a little bit of background noise from my kitchen. There's the most popular name with a count. Oh, now we've got a problem. What about I just want the name? How do I get rid of what's here? Cut has another option for us. So cut, as well as dealing with character separated data, you can also specify character. You can specify the column, the character position. So I can say the cut.
Your head's getting in the way again, Andrew.
Oh, well, no. All right. Apologies for my head. So I want to get rid of these characters there. I have a way. I can say to cut, print out character positions 1, 6, and 11 on with a command like that. I'm not sure what that'll do, but there's some data. And there it's giving me character 1, 6, and 11 on. So cut will let you say there's no separators, just give me these columns, if you like, these character positions. So I think I can then go cut dash C. What would that be? 9 dash? Oh, there we go. So there's a pipeline of 1, 2, 3, 4, 5, 6, 7, 8 programs chained together, passing their output to input to tell me what the most popular family name is, what the most common family name is in the class. The dash n there, by the way, actually isn't needed because the numbers are right formatted. You can think about that. Lorenzo's asking, what happens if you go dash T without a dash K to sort? I honestly don't know, but again, we have these lovely CSC servers and lab machines, and
I
that's what
can
it
tell
does.
you that one. Sort is a little different from cut. Cut defaults to tab. Sort defaults to word breaks. So any non-word character, so white spaces or underscores, is or a sequence of white spaces or underscores. So without saying a T, that input there would have 2 fields. The first one would be the number, the second one would be the name. It doesn't matter how many spaces or tabs are separating them. There would always be the first and second field for sort. Cut would see that in a different way.
So there are questions in the chat about this option to tail, and you're right, it's a weird option. You can say dash number. That's not a normal way of doing options, and it doesn't fit the pattern we showed you in Monday's lecture. It's because tail and head are really old programs, basically. You can write the option in the more traditional way by saying dash N3. There's probably a long form. Is there a long form? Dash lines. Yes, there we go. So I could also write it. And people sometimes, when they're writing scripts, use the long form because they think it makes the scripts more readable. Well, it does make the scripts more readable. Saying tail, give me 3 lines. So that saying dash dash lines 3, saying dash N3. So that's pretty common. We talked about that, how often options that change the behavior of a program have a short form and a long form. Dash dash long form, single dash short form. But tail is really weird in that I can just put the number there with nothing. So that's does not fit the pattern of other programs. As I said, we're seeing things that are far less. If you're designing this whole suite of filters from scratch, you wouldn't do things like this. You'd be more consistent. All right. I want to show you a couple more filters put together. Well, actually, I've got a little time. There was something I wanted to show you about the enrollments as well. All right. Now, this data is quite weird. Well, the data's not weird. The data is how it's been rendered is weird. Names are particularly problematic in for programmers, for coders. There's almost nothing you can assume about people's names that universally holds. Someone helpfully pointed out the names of Elon Musk's children, and with, I think, have very unusual characters in them. I can't remember. I didn't actually pay a lot of notice. But there are lots of cultural things about names. There are a few areas not so far from Australia where we get students where it's pretty common to have one name only. I think it's parts of Sri Lanka and maybe also somewhere in Indonesia that this is not uncommon. The UNSW student record system doesn't cope well with that. The solution was, I think, if a student had just one name, that was rendered as their family name, and then they had a dot instead of another name. My generation of syntactic data here hasn't handled that very well, and it's given people with no first name but a middle name. But again, you will get people who say, no, I don't have a first name, I do have a middle name. That happens. You get all sorts of weird things. You get people with spaces in their last names. That's very common. Or that's just, you should, if you're coding, just assume as little as possible as you can about names, and your life will be happier. You might have the bright idea, I can identify something about people from their given names. No, you can't. All right. So what if I wanted to look with people who had no first name? How would I do that? I wanted to show you that. Your first thought might be something like...
Oh, and UNSW only stores 50 characters of your name. So if you have a very long name, that's unfortunate for you.
And you might think, well, that seems okay. No one's going to have a 50-character long name. That's also a long name. There are, I think it's Sri Lanka. Very long names are common. That's probably not the only place. So we do get students whose names don't fit into the UNSW fields. We also get students whose names aren't ASCII. That's, well, pretty common, really. And for 1 year, UNSW's IT system let non-ASCII characters creep into student names. So if you're writing code that works with the enrollment data, there's just 1 year where there are Latin encoded characters in the data. This is the lot of a programmer. All right, so I do this, and we'll quickly discover it doesn't do what I want. It's picking up Madeline there, for example, who I was looking for, but not. Why not? All right, when you see a regular expression, always get nervous about unusual characters. So you're safe with letters, A to Z, capital A, little a to Z, capital A to Z, num digits, but after that, you've always got to worry about special meanings on things. Comma, as it turns out, doesn't have a special meaning generally in regular expressions, but we've seen dot does. Dot is super convenient. It means match any other character. Now you could specify that in the old form of regular expression. You could sit here with your keyboard saying it's a Q or a W or an E or an R, and it would be very tedious going through all the possibilities. Or we can just say any one character. So we can turn that off with a backslash. So we can, that says there. Notice I've got quotes around the regular expression. That regular expression has two things in it that mean something to the shell. The space means something to the shell. That means shell uses space as a separator, and the backslash does as well. But we put in a single quote so the shell won't treat them specially and just pass them through to grep. And that finds all the people who have got dot as the first name there in this data, in this weird data. Oh. one thing I wanted to show you is a really nice trick you can do with dot. So let's look, I don't know, J and Q are pretty uncommon name characters. Let's see if we can find someone who's got, let's see what matches this. Oh, only one student in the whole data matches this. Alright, now look at my regular expression there. What does it say? J and Q. Yeah, okay, they have no special meaning. There's no anchor, so the J can be anywhere in the data and the Q can be there. Where's the Q in this line? Oh, there's the Q. We could cut and paste that into regexer, and regexer will help you. I'm quite keen to see this happen. As I said, I don't use regexer on myself, so I'm quite keen to see this. Can I paste you in? Oh, ooh. All right, bear with me as I fumble about trying to use this. There we go. Regexer is showing me the part of the string there that got matched. Explanation over there. Good explanation over there. That's lovely. Let me try my own explanation. Dot. You know what dot means, and you know what asterisk means. Dot means match any character. Asterisk means match 0 or more of whatever's before me. Because there are no brackets, it just means dot. So that says 0 or more dots. So that means any number of any character. Something you use so often with regular expressions. That, by the way, gives me an infinite set. So that gives me a set containing the strings capital J Q, capital J any character Q, capital J any character, which is 256 strings probably if we're assuming bytes, capital J any 2 characters Q, which is many more strings. So it gives a very large, specifies a very large set of strings. Now, that's quite nice. Let me show you doing something else with it. The one thing it won't match is a Q before a J. That's a different regular expression, and gets a lot of matches a lot of things. I'm very fond of vowels. Do we have any names with 3 or more vowels? Now you're thinking, I can write it like that. That will give me.
Actually, you're getting very close to a Lab 1 solution here, Andrew.
Oh. All right. So I'll thank you for that. I did try. I didn't get a chance to. I meant to skim the lab. I've done that before. I don't like giving out lab solutions in lectures. All right, so let's move to a different topic. Yes, Blake's going to put Newline in his name. All right. Now, I want to look at a different thing. Then let's go back in time. Okay, let's cut the data and get field 1 and field. We'll go with 4, which is the degree you're in. I should say what's happening here because it's a common trait. You're thinking here, why aren't I getting output? Why is this running so slowly? What happened here? I forgot to put a file there from cut. So what does it do? it tries to read from the enrollments file. Sorry, I forgot to put the enrollments file, so it tries to read from standard input. Alright, so you generally realize pretty quickly you've done this on the command line, but if this is buried in a script, it can be harder to spot. So this can be something to remember. If you stuff up and forget files, your script, these filters will start reading from standard input. So we'll get the first four.
Fortunately, this will be something that we'll see in the next couple of weeks. We have a program called Shell Check that we'll be introducing in the next couple of weeks, and I believe that instance, what Andrew just said, is something that program will be able to bring to your attention if you accidentally make that mistake as we're writing scripts in the next few weeks.
Oh, I'm forgetting the dash E. I keep forgetting the dash E. Alright, there we go. That's printing all of one line for everyone enrolled in this course, COMP2041 or COMP9044 is the postgrad course code, with what degree you're in. Alright, I'm just interested in the degrees now, so not this time for sure. So there's using a backslash to protect the pipe from the shell, and there's using quote to do the same thing. So that's got a list of the course codes that people are enrolled in. It's got the stage here too. Say this person's in stage 2, stage 1, stage 4. It doesn't mean a lot, honestly. It's a sort of an archaic concept. But I can get rid of those if I want by saying cut on the slash and just give me field 1. And maybe I'll sort these as well. So there is, well, these numbers don't mean a lot, do they? But here they are with program codes in this file. So I can refer to this file and see that, you know, it tells me that program code 1400 psychology and so on. So I could look up program code 8959, hopefully in this file, and discover that's data science and decisions. There you go. How do I put those two together? There is a program called join. It doesn't get used so much, but it's more to alert you. So these things I've shown you, cut, sort, unique, WC, if you're going to work on this sort of data, you were using them just all the time. A lot of people would, like me, would use them daily. Join is one that you use much less often. The sort of things you use join for these days much more often would be replaced with, for example, with a Python program or maybe a similar language. Yes, you can, if you've got enough data, yes, SQL is your friend here, but sadly we don't have time to get into SQL in this course. But there, join puts together the numbers in standard input.
Head again, you're going to have to clear your screen.
Why is my head so big? Alright, so, oh, that's still got my head in the way. Here's join saying, read numbers from standard input and join it together with the data in the file. You can perhaps play with that. We're about out of time. I'll just show you one more version of it. This is one of the things I sometimes have to look up myself. I'm trying to remind myself of what the exact command I wanted to show you is. There we go, that's what I wanted to see.
A couple more new lines still behind your head.
Here's a pipeline to finish with. perhaps with a more, showing you accounts for each degree of people in this course. So postgrad information technology, 222 people, undergrad computer science, 195, engineering honours, which is probably mainly software engineering, 93, commerce computer science, 52, engineering honours joint degree with computer science, 45, science computer science, 28, data science decisions, 23, actuarial science computer science, 21. These are counts combining that data. Let me push that above my head. So that's sort of showing you at the limit the sort of thing you can do combining these things together. Perhaps that's going a bit far, but we'll look at doing things in shell scripts and recap some of this stuff next week. Sadly, we're out of time together, but hopefully I've convinced you of the power of these programs, these Unix filters, and how sometimes this last couple, maybe we've got into some things that are a bit complicated and scary, but hopefully you've already understood some of the simpler examples we've run. Next week's tutorial and lab will recap regular expressions, more chance to practice your regular expressions, and walk you through learning to use these tools to solve problems. So yeah, don't worry too much about the join command. We'll revisit at the start of the next lecture, but it's sort of more of an advanced optional extra than a core thing. All right, thank you all for your attention, and thank you for your patience. I'll talk to you all Monday next week. Good luck for those of you who haven't had your tutor labs with working out in your tutor lab. Don't panic, because lab exercises normally due Monday, but you've got an extension because it's the first week of the course. Thank you all for the interesting commentary from the chat as well, and thank you, Dylan, for helping out today. See you all on Monday.